Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So today in this video we continue with the last question of the tutorial, which is question 21. Okay, for question 21, the question asks you to find, okay, we start with the question first. An airplane flying horizontally at a speed of 150 meter per second. Okay, it drops a box from elevation of 2000 meter. Okay, so if I want to draw the situation, it will look something like this. Okay, the common misconception is that student thinks that whenever box is being dropped, it is being dropped backward, which is not true. Okay, because you can imagine you're basically holding the airplane is basically holding the box. Okay, so when the box is being released, it has a initial velocity, the same velocity with the airplane. So it will be u equals to 150 meter per second as well, and it is going to be to the right, which is the same direction with the airplane itself. Okay, so the one, if you imagine that it's going backward, you actually imagine what will happen when you're sitting inside the airplane. If you're sitting inside the airplane, obviously you will see that this box looks like it's travel backwards, because this airplane continue at the same velocity, which is 150 meter per second. But now we are talking if you are looking it from outside of the airplane, let's say from the bottom here on the ground, you can see that this box actually will travel forwards, initially with the same velocity of the airplane itself, and then it will goes forward and it drops at a certain position. So here they give you the height of 2000 meter. So in this case, you can imagine something similar to the one that if you release an object from inside the car. Okay, you can imagine that. Okay, so how much time does it take for the box to reach the ground? Okay, time. So again, this is the formula that I have already put it here. So you can choose now. If you want to find time, you do know your sy. You don't have the sx, right? So you cannot use the x component, so you have to use the y component parts. Okay, you do know the sy, you want to find time, so you can cancel out this equation first. Okay, and since you don't have the vy yet, so you cancel out this one as well, so you left with the third equation. I'm gonna write that one down here. So you know that sy is equals to uyt minus half gt square. Okay, since initially when the box is being released, it has a velocity of 150 meter per second, this one to the right. Okay, so that means your uy is equals to 0. And this one is similar with the case when the object being released horizontally. Okay, so this one becomes 0. Sy is negative 2000 because this one is your starting height, right? So this is when s equals to 0. Anything below is negative, so it's negative 2000 now equals to negative half 9.81 t square. Okay, obviously the negative will cancel out, so you have 2000 multiplied by 2 divided by 9.81, the square root. Okay, I got here t is equals to 20.19 seconds. Okay, that one's for question A. Okay, oops. Okay, for the next question, question B, the question asks you to find how far does it travel horizontally. This actually asks you to find sx, because how far it travel horizontally represent this distance. So this is the starting point, this is the sx. Okay, so you do have the time now, so you can straight away use sx equals to uxt. Since ux is 150 meter per second, t is equals to 20.19, so your sx will be 3028.5. This is in SI unit, so final answer would be in SI unit as well. Just want to write this one properly. 20.19. Okay. Again, I make this one a little bit smaller. Put it over there. Okay, so A and B is done, completed. How far? You find the horizontal and vertical component of its velocity when it strikes the ground. Okay, this one is interesting. Okay, you do know the ux, right? So ux is equals to 150 meter per second. This would be your vx, okay? Because as you guys know, the horizontal component of the velocity wouldn't change, it will be remains constant. So if this one is 150, over here will be 150 as well. Okay, so I'm going to leave it like that. For Vy, you can find Vy using either of these three equations. Okay, since you know the time of flight, so time taken from here to here, so you can calculate. Okay, like I told previously, common misconception. Student thinks that when it strikes the ground is after it strikes the ground. Some student they think that this one is 0, which is not true. The question actually asks you just before it reach the ground, before it lose any energy. So I can use the first equation. Vy equals to uy minus gt. Okay, uy is equals to 0 because there's no component in there. There's no velocity in y component. So this will be 9.81 multiplied with the time that we got just now, which is 20.19. So 9.81 times 20.19 I got here is negative 198.06. Okay. Okay. So the negative here represent the direction. Okay. And in this case, it will be downwards. So because the question asks you to state separately, because the question actually asks find the velocity, horizontal and vertical velocity. So I think I'm gonna write down properly. So like this one, you really need to write down the unit and direction. So minus 1, ms minus 1. Okay, then I'm gonna make this one smaller. I'm going to write down the conclusion down here. So for vector, it's best if you can rewrite the final answer. So therefore, Vx is equals to 150 meter per second to the right, and Vy is equals to 198.06 meter per second downwards. Okay, so you don't have to write like I mean this kind of sentence is enough. Okay, this one smaller as well. Okay, so that's that. So we answer question up until C. Now the last one is, what is the velocity of the box when it strikes the ground? So just now we calculated these values over here and this value over here. So now we want to calculate the V, which is basically just the magnitude of those two components. So I'm going to redraw the Vx and Vy over here. So you can imagine that Vx is here, this is Vy. Okay, if you want to be particular, Vy should be longer than Vx because the magnitude here is bigger compared to the Vx. Oops, what did I do? Okay. This would be your V. Again, always put your theta towards the x-axis. Okay. Now you can calculate V, which is equals to square root of Vx square plus Vy square. So your Vx is 150. Okay, 198.06. Just put the magnitude because that one is square, so it doesn't really matter. Okay, plus 198.06 square. Take the square root, I got here straight 248.45 meter per second. So if you leave your answer like this, it wouldn't be enough. Okay, you really need to find the direction. Resize, smaller, put it there. You know, for the direction, you can use tangent theta equals to y component over x component, which is vy over vx. So this is based from your diagram, your diagram over here. So vy is equals to 198.06. Okay, again, notice that I didn't put any negative in there because I just want to calculate the magnitude here. We already draw here, so we know the position of theta there should be there, so I don't have to put the negative inside the calculation. Okay, got here is 52.86. Okay, so it's best if you can write down the direction in terms of word as well, which is below positive x-axis. Okay, so that's it for the tutorial question from question 1 until 21. Hopefully I covered most of the questions. If let's say if you have any question, you can always WhatsApp me or contact me. And now you can do the pass as well. Okay, so thank you.